You glance at a revenue chart. 2023 is the tallest bar. You subtract a couple of numbers and you feel done. Then, a second too late, you notice the label on the axis in thousands of crores. You'd been reading the numbers as plain crores, and the question asked for a ratio, not a difference. Your arithmetic was correct for the wrong quantity and the wrong operation. That is what data interpretation really tests, not hard sums. Reading in the right order and choosing the right operation. So we'll keep one fixed routine for every chart and table. Read the axis, the labels, and the units first. Then the legend and any notes. Then the whole question, deciding what operation it wants. And only then do we touch the numbers. Almost every question leans on the same small toolkit. 4 operations, and one extra for when groups have different sizes. Let's name them once, cleanly, so we never mix them up later. A difference is just a minus b. How much bigger one thing is than another. A ratio is a over b, then simplified. How many times one is of the other. 200 to 80 is 5 to 2. A percentage is part over whole. Times 100. What share one piece is of the total. Percentage change is new minus old over the old value times 100, the growth or the drop. Notice, always divide by the old number, and an average is the sum of the values over how many there are. Keep these 5 in your pocket, and most charts fall over quickly. Start with the plainest display of all, a table. Rows are 3 schools, columns are 3 years, and every cell is a head count of students. Read the headings first, always. Rows, columns, and the unit, students. First question. The total students across every school and year. Add each school's row. North Star 1500, Riverside 1200, Hilltop 900. Sum those, and the grand total is 3600. Second, what share of all 2023 students went to North Star? This is part over whole. The column for that year totals 1500. North Star's cell is 600. 600 over 1500 times 100 is exactly 40%. Third, the ratio of Riverside in 2023 to Hilltop in 2021. Pull the two cells, 500 and 200. 500 over 200 is 5 over 2, a ratio of 5 to 2. Fourth, and this one has a sting, which school grew fastest from 2021 to 2023? Every school added exactly 200 students. So by difference alone, it's a three-way tie. But growth means percentage change over the starting value. North Star added 200 onto 400, 50%. Riverside, 200 onto 300, 67. Hilltop added 200 onto just 200, a full 100%. Same absolute jump, very different growth. Hilltop wins. Last, the average school size in 2022. 3 schools. So add that column, 500, 400, 300, and divide by 3. 1200 over 3 is 400 students per school. And a which is largest question. Which year enrolled the most students in total? Don't compare single cells. Compare the column totals. 900, 1200, 1500. 2023 is the biggest year, and the totals climb steadily, which itself tells a story. Now a bar chart. The same sales, but a picture. 4 quarters across the bottom. Sales up the side in lakhs of rupees, and 2 bars per quarter. One blue for 2022, one green for 2023. What were the total sales in 2022? Read only the blue bars. 120, 180, 150, 200, and add them. 650 lakh across the year. What percentage of the year fell in the fourth quarter? Part over whole. 200 over the annual 650 times 100. That's about 30.8%. Call it 31. The ratio of the second quarter to the first in 2022. 180 over 120 is 3 over 2. 322. And here's the classic slip, answering 180 minus 120, 60. That's the difference, not the ratio. How much did the fourth quarter grow from 2022 to 2023? Percentage change. New minus old over old. To 60 minus 200 is 60. Over the old 200 times 100, 30% growth. And which quarter grew the fastest? You must compute the percentage change for each. You cannot eyeball it, because a big bar can grow slowly. The first grew 25%, the second only 11, the third 20, the fourth 30. So the fourth quarter grew fastest. Bars sometimes come stacked. One bar split into pieces. Here the whole of 2022 is a single column, cut into its four quarters, piled one on the next. The bar's full height is the annual 650. Now the trap that catches everyone. What were the second quarter's sales? The top of the green segment sits at 300. But that's the running total up to and including it. The green piece starts at 120, where the blue ended. So the quarter's own value is its top minus its bottom. 300 minus 120, 180. The height of the segment, not the height it reaches. Always read a stacked segment by its thickness. And the fourth quarter's share of the whole bar? Its thickness is 650 minus 450, 200. And as a fraction of the full 650, that's the same 30.8% we found before. The stacked bar just tells the same story a different way. And a ratio between two segments, the fourth quarter to the first. Read each by its own thickness. 200 and 120. 200 over 120 simplifies to 5 over 3. A ratio of 5 to 3. Never take it from where the segments reach, always from how thick they are. A line graph is built for trends over time. Months run along the bottom, users up the side in thousands, and the line simply joins each month's dot to the next. Let's watch it draw itself. The peak is the easy one, the highest point on the line. That's June at 90,000 users. Read straight across to the axis to confirm the height. Which single month rose the steepest? The steepest segment is the one climbing fastest. Month to month, the jumps are plus 5, plus 15, plus 10, plus 10, and plus 30. The biggest leap, 30,000, is from May to June. What was the overall growth from January to June? Percentage change again, new minus old over old. 90 minus 20 is 70, over the starting 20. That's 350%. The user base grew 3.5 times over. And the percentage growth from February to March alone? 40 minus 25 is 15, over the old 25 times 100, 60%. Notice February to March added only 15,000, yet grew 60%, while May to June added 30,000. A bigger jump isn't always a bigger percentage. Finally, the average users per month. Add all 6 months. That's 285,000 and divide by 6. 47,500 on an average month. And notice the average sits well below the June peak of 90 because the early months drag it down. A pie chart shows shares of a single whole. Here, 400 students split by branch. Each slice is a percentage, and every slice together makes 100%, the full circle. How many students study mechanical? The slice says 20%, but a percentage is only a proportion. To get a count, multiply by the total. 20% of 400 is 80 students. Mechanical and civil together? Because both are shares of the same total, you can simply add the percentages first. 20 plus 15 is 35%. Then take 35% of 400. That's 140 students. The ratio of computer science to other? Computer science is 120 students, other is 40. A ratio of 3 to 1. And here's a shortcut. Since both are slices of the same total, the ratio of the counts equals the ratio of the percentages, 30 to 10. Same, 3 to 1. One more the pie makes natural. The angle of a slice. The full circle is 360 degrees. So a slice's angle is its percentage times 360. Computer science, 30%, sweeps 30% of 360, 108 degrees. The hardest questions make you read across two displays at once. On the left, a table of prices. On the right, a bar chart of units sold. Neither, by itself, tells you the money made. You have to combine them. Revenue is price times units, product by product. Pens, 10 rupees times 300 is 3000. Books, 50 times 200 is 10,000. Bags, 200 times 35 is 7,000. Now, which product earned the most? The trap is to grab the tallest single bar. But bags has the highest price and pens the most units, yet neither wins. Books, in the middle on both, brings in 10,000, the most of all. You only see it by computing the product. Total revenue is the sum of the three 20,000 rupees. And book share of that? 10,000 over 20,000 times 100, exactly 50%. Half the money came from the product that never had the tallest bar on either chart. Not all data comes as a chart. Sometimes it's a short paragraph, a caselet, and the trick is to picture it. 60 people like tea, 50 like coffee, and 20 like both. How many like at least one of the two? Draw two overlapping circles. The overlap is the 20 who like both. So tea only is 60 minus 20, 40. Coffee only is 50 minus 20, 30. Adding a plain 60 and 50 would count those 20 twice. So the count who like at least one is the size of the union. Tea plus coffee minus the overlap counted twice. 60 plus 50 minus 20, 90 people. Subtracting the intersection is the whole game with overlapping groups. Your turn. Same pie, 400 students. For the electronic slice, find two things: how many students it is and how many degrees its slice sweeps. Pause the video and work them both out before I do. Here's the check. 25% of 400 is 100 students, and the angle is 25% of 360 degrees, exactly 90 degrees, a perfect right angle wedge. If you got 100 students and 90 degrees, you've genuinely got this. 5 traps sink most people. So let's name them. The first, confusing difference, percentage, and percentage change. Sales rise from 100 to 150. The difference is 50. The percentage change is 50 over 100, 50%. And a slice worth 200 out of 650 is 31% of the total. 3 different questions. Know which one is being asked. Trap 2, the stacked bar. A segment's value is its top minus its bottom, never the height it reaches. If the green ends at 300 but started at 120, its value is 180. Read the thickness. Trap 3. A pie slice is only a proportion. 30% is a share, not a head count. Without the total, you can compare slices as ratios, but you can never turn a percentage into an actual number of people. Trap 4. Averaging averages. Two classes. One averages 60 with 10 students, the other 90 with 30. The plain average of 60 and 90 is 75. But the true, weighted average leans toward the bigger class, 82.5. Equal weight is only right when the groups are equal in size. And trap 5. Don't eyeball and don't overread. If a bar lands on the grid line marked 100, its value is 100, not 102.3. Read to the precision the graph actually shows, and when in doubt, compute rather than guess. Let's lock it in. Every chart yields to the same routine. Read the units, then the legend, then the whole question, and touch the arithmetic last. Your toolkit is tiny. Difference, ratio, percentage, percentage change, and average, with a weighted average when groups differ in size. And you've now read every common display. The table, the bar, the stacked bar, the line, the pie, two charts at once, and even a caselet in words. Keep 3 formulas close. Percentage change is new minus old over old. A pie slice's count is its percent times the total, and its angle is its percent times 360. Read carefully, name the operation, and any chart or table becomes routine.